Welcome back. In this lecture, we will look at nuclear reaction that can be induced by protons or deuterium. Protons are particularly advantageous because they can be accelerated in a particle accelerated, and the very high energy proton can be obtained. So the energy of proton can be few keV, 2 giga electron volts. And so a variety of system can be studied using proton-induced reaction. So even at low energies, proton can induce nuclear activity. So some of the examples of proton-induced nuclear reaction are mentioned here. So as you can see, uh, proton is a projectile. Uh, a variety of products can be formed. You can have gamma radiation or a neutron emission or an alpha particle emission. This reaction is of historical importance because using this reaction, Einstein's energy mass equivalence was demonstrated. This provided the experimental evidence for proving this relationship. So here a proton is used as a projectile, and eventually you get alpha particle. When you have a 0.5 MeV proton as a projectile colliding with a lithium atom, you produce a very unstable beryllium atom, which decays to two alpha particles. So the overall reaction is the following. Uh, it is also possible to generate multiple particles after impact with a proton. Supposing you use a 20 MeV proton onto boron, you get carbon 6, 12, and this decomposes into 3 alpha particles. Okay, this is a very well studied reaction, this particular reaction. So in we have also seen multi-particle producing nuclear reaction in some previous lectures. For example, we have shown this plot when we were elaborating cross-section, nuclear cross-section. Here, you see there are many reactions where the exit channel have more than one particle. You have proton, neutron here, and so on. Okay, so this is one of the example here. You have two neutrons and so on. Okay, so there are many nuclear reactions wherein multiple particles can be produced as products. Compared to proton, deuterium is even more interesting from the point of reactivity because deuterium has low binding energy. So its capacity to induce nuclear reactions is even more than that of proton. For example, in this reaction, deuterium is a projectile colliding with carbon will generate this nucleus. Likewise, with phosphorus, you form this particular nucleus. In both these cases, what is emitted is a proton. Okay, so deuterium is the projectile, proton is the ejectile. So besides proton, you may have other emissions. For example, here in this system, neutron is emitted. In both these systems, neutron is the ejectile. You can also have other particles beyond neutron and proton. For example, in this, deuterium is the projectile. It is colliding with oxygen, and you form nitrogen, and you generate an alpha particle too. This is a particularly interesting reaction where deuterium reacts with deuterium to form tritium. All these things are very important from in energy perspective. This can be occurring in the sun and so on. So these are very well studied reactions. Here, deuterium gives rise to isotope of helium. In both the above cases, it is thought that the compound nucleus that is formed is this is the compound nucleus that is formed, and after that they decay to a variety of products. Okay, so these are fairly well studied system, both theoretically and experimentally. So in the next brief lecture, we will look into uh, photonuclear reaction and heavy ion induced nuclear reaction. Thank you.